Hello everyone. So today we will introduce a new exercise. We will perform linear discriminant analysis, or known LDA, to separate the iris dataset. So the first step is we're gonna try to import the libraries that we're gonna use in this exercise. So import numpy as a np, import pandas as a bd. Also, we will import the iris dataset. So from sklearn dot data sets imports load iris underscore between the two words iris, and we will also split data set into training and testing. So from sklearn dot model underscore selections or selection, sorry, import train tests and split with underscore between each word as TTS for a shortcut. Now we will import from the sklearn. So from sklearn we want to have the discriminant analysis. So dot discriminant underscore analysis. Now we want to import the linear one, so import linear with a capital letter. Sorry for the typo, linear. Then discriminant, sorry, with capital letter in the beginning. So discriminant and analysis with capital letter in the beginning. Now also we assess that the performance for this one. So from sklearn want to have metrics. So import accuracy underscore score, and you can also import the confusion matrix if you want to. So I think I have a typo here. Model, let's see, model underscore selection, import train test split. Also I have another typo here. Discriminant underscore analysis, and this one I think I put it wrongly. And I'm gonna run this one. I think it will be working now. Okay, so it works. Now let's start loading the iris dataset. So iris equals load of iris, open and close banana bracket. Now we're gonna define x here. So x equals iris dot data, and y equals iris dot target. Afterward, now we want to show the data how it's look like. So let's call the matplot. So import matplot lib.python plot as a PLT. There is also another one could be help. So import Seaborn as a SNS. Now we want to plot the data set here. So PLT dot figure to determine the figure size. So figure or fig size equals, let's make it between 10 and 5. You can adjust it if you want to. Now we want to plot the data between the first two features at the beginning without applying the discriminant linear analysis, and then we want to try it out after applying the discriminant analysis. And if you remember from the lecture, discriminant analysis is compression the data based on the difference between the groups divided by the difference within the group. And basically applying this methodology, we can see how the data will be shrinked and to lower dimension or lower rank. And we want to try to compare it for two features before doing the compression and after doing the compression. So we want to plot the two ones side by side. So PLT dot sub plot. So we want to have two figures side by side, and this is going to be the first figure. So SNS dot scatter plot. Now open. Now we're going to define x. So x equals the first feature, which is 0, versus we have the second feature. So this is will be in your y-axis x for the second one, which will take 1. Now we will basically put the target here. So hue equals y. Now we're going to add more information. So palette equals the VIRIDIS and marker will equals O. Now we can also add the title here. So PLT dot title will be first two features with target, and then we're gonna add the x-axis. So PLT dot x label, which will be feature 1, or you can name it, so the length of the iris or the width as the data suggests. It doesn't matter about double quotation or single, but I want to make it consistent. plt dot, sorry, we're gonna have the y label, plt y label. So this will be the second feature, so feature 2. Now we're gonna add the legend, so plt dot legend will be title equals the target, and you can put its position, so we can look it, so location will be upper right. And after doing that, let's apply the linear discriminant analysis. So before that, let's split the data. So here, splitting the data into training and testing dataset. So here we have X train, X test, Y train, and Y test will equals TTS for X and Y, the test size underscore size equals 0.2, and here we want to add the random state equals 1, 2, 3. After that, we will start building the model. So building the model, we have LDA equal. So let's make shortcut here. Okay, I can just copy it. Linear discriminant analysis. And here we can take the default number of components. So let's make it as whatever it takes. Now we're going to define the X of the LDA to fit the model. So X equals LDA dot fit underscore transform. This is going to be for X train and Y train. Now, after initializing that, we want to assess the model. So we want to determine the accuracy. So predict Y test. So this is gonna be X test for the LDA equals LDA dot fit underscore transform, and for the X tests. So since we started drawing the whole data set here, Now let's compare it with what we ever have gotten from the training. Okay, so this is just only for demonstration. So plot the trained classification. So we're gonna start with where is the plot. So PLT sub plot will be 1, 2, and 2, and then we will have the SNS dot scatter plot. You're gonna define X this time, so X gonna be the LDA transformed. So it's gonna be this one. We're gonna just only do the first component here for this one. Then we're gonna define Y. So Y equals again XLDA for the second component. We can determine the target. So U equals Y. Now Palette equals Verdes, and marker equals O. Now we're gonna add the title. So PLT dot title. This is gonna be classification using LDA. And now we're gonna add X label. So X LTX label will be for the first LDA component. So LDA component 1, and then we're gonna add the second one here. So PLT dot Y label LDA component and we can do the legend PLT dot legend. So it's not it's the same thing we have done. So title equals target, and we will put it in the same location. So location or loc equals upper right. And we can now calculate the accuracy. So accuracy equals accuracy score between Y tests and let's keep it later because I want to use the confusion matrix. Okay, I forget to put plt.show, plt.show, and I'm gonna run it. Okay, so in number 25. Okay. here say y test so I trying to take a more